Good morning. I am Kavita, working as assistant professor in Sri Muthukumaran Institute of Technology in the Department of Computer Science and Engineering. Today I am going to present a topic in Introduction to Operating System. The subject code is CS3451. Today I am going to present a topic in CPU scheduling. First, what is CPU scheduling? CPU scheduling, which is nothing but it is a method used by an operating system to decide which process should use the CPU next. And then when one process is writing for input or output device like keyboard, the keyboard, printer, and disk, the CPU should not be idle. The operating system switches the CPU to another ready process. So the main goal of a CPU scheduling is increase CPU utilization, improve system speed, and make sure the system fair to all process. Who decide which is who decide the CPU scheduler? The shortest term scheduler selects one process from the ready queue and assign the CPU to use it. And then types of CPU scheduling. The CPU scheduling make decisions to take place under the following four circumstances. That is, there are four types of situations. One is running to waiting, running to ready, waiting to ready, and process terminates. For example, the process request input output in the running to wait state, and running to ready means if any interrupt occurs, and then waiting state is waiting to ready state. If the system needs any input output devices, so after completing, then go to the ready state and process terminate. If all the process complete, the process get finished and then get terminates. All this process, the operating system must decide which process run next. uh, Types of scheduling. One is preemptive scheduling and non-preemptive scheduling. Preemptive scheduling, which is nothing but a running process can be interrupted, and the CPU is giving to a higher priority process, and it used in modern operating system. For example, round robin and preemptive priority. And in non-preemptive scheduling, a running process cannot be interrupted. CPU is released only after completion. Example, first come first serve, non-preemptive, and shortest job first scheduling. Next, the CPU algorithm. There are four types of CPU algorithms. One is first come first serve, shortest job first scheduling, priority scheduling, and round robin scheduling. In first come first serve, there is a problem. There are process. There are five process working in a CPU: P1, P2, P3, P4, and P5. The burst time for P1 is 9, P2 is 33, and P3 is 2. P4 is 5 and P5 is 14. Suppose that the process arrive in the order P1, P2, P1, P2, P3, P4, P5. While applying first come first serve, the process are executed in the order arrives. Example, arrive order is P1, P2, P3, P4, and P5. It is simple and easy to implement but causes long waiting time. The average time, how to find the average time is, um, first, it is based on the first come first serve. So first P1 is enter, it complete the process. After 9 milliseconds, it complete the process, and then P2 enter. It works and complete the task in 33 milliseconds. Likewise, all the process comes and use the CPU. The waiting time for P1 is 0 because there is no waiting time for P1 because P1 is enter first, and then P2 arrives, but waiting time is after completing P1, then only P2 enter. So the waiting time for P2 is 9 and P3 is 42. How 42 means, the waiting time for P1, P2 is 9 plus 33 is equal to 42, and 42 plus 2 is equal to 44, and 44 plus 5 is 49. So likewise the waiting time is calculated, and then average waiting time is adding the waiting time, 0 plus 9 plus 42 plus 44 plus 49 divided by 5 is equal to 28.80 milliseconds. And then shortest job first. In shortest job first, the process with smallest burst time execute first. So smallest time, burst time is P3. P3 is having burst time 2, and then P4. P4 is 5, P1 is 9, P5 is 14, P2 is 33. So based on the smallest burst time, it will it will give priority. So the waiting time for P3 is 0, waiting time for P4 is 2, because P3 have not no, there is no waiting time for P3. So after completing the process of P3, P4 enter. P4 enter and waiting for 2 milliseconds after completing P4, and then P1 enter. Likewise, all the process enter. So based on the waiting time calculated, the average waiting time is nothing but 0 plus 2 plus 7 plus 16 30 divided by 5 is equal to 11 milliseconds. And in priority scheduling, CPU is given to the process with highest priority. That is lower number, it will give the highest priority. So here process P1, P2, P3, P4, P5, the burst time is P1 for 10, P2 is 1, P3 is 2, P4 is 1, P5 is 5. So here they given the priority 3, 1, 4, 5, 2. So the priority, which one will take the shortest, the lower number. So 1. So 1 means P2 enter first, and then 2. So P5 enter, and then 1, and then 3. So P1 enter, and then 4. P3 is enter, and then 5. So P4 is enter. Likewise, the waiting time is calculated. After finding the waiting time, average waiting time is 0 plus 1 plus 6 plus 16 plus 18 plus 19 divided by 5 is equal to 8.2 milliseconds. And then round robin is nothing but each process gets CPU for the fixed time quantum 8. Here mentioned 8. So each and every process only 8 milliseconds have to work. So first P1 is enter. So it use 8 time slice, and then P2 enter 8. P3 is having only 2. So in the time slice of 8, only 2 will occupy, and P4 is enter. Likewise, all the process complete the process. The waiting time for each process is as follows. P1 waiting time is first it will get 0, and then again P1 enter here. So the waiting time is 23. So 0 plus 23 is equal to 23, and P2 enter here 8, and then again here P2 is coming. So here the waiting time is 16, and then P2 enter here. So 6, the waiting time is 6. So 8 plus 16 plus is equal to 30, and then P3 is coming. While P3 is coming, the waiting time is here 16, and then there is only one P3 occur, and then P4 enter. P4 having 5 burst time. So only here only P4 occurs. So the waiting time for P4 is 16, and then P4 enter. P4 waiting time is 18, and P5 enter. P5 is here come. So waiting time is calculated 23 plus again here. So the waiting time for the waiting time for the process is 9. So is equal to 23 plus 9 is equal to 32. So therefore the average waiting time is calculated based on the waiting time. So 23 plus 30 plus 16 plus 18 plus 32 divided by 5 is equal to 23.8 milliseconds. So multiprocessor scheduling. Multiprocessor scheduling, which is nothing but used when a system has more than one CPU. The processes can run in parallel, and also operating system decide which CPU must run which process should enter, and improves performance and throughput. It is used in the multi-core systems. And then real-time scheduling. In real-time scheduling, it is nothing but it is used to when a system has more than one CPU. The process can run in parallel. In real-time scheduling, the operating system decides which CPU runs which process. It improves performance and throughput. It is also run in the multi-core system. And in real-time scheduling, it is used in real-time applications, for example air traffic control, medical systems, and robotics. In real-time scheduling, the task must complete within the deadline. The task must complete within the deadline, and the highest priority process run first. It execute hierarchy priority should be execute first, and very strict timing constraints followed by the real-time scheduling. And next topic is thread. Thread, which is nothing but a thread, is a flow of execution to the process code when its own program counter and the system register and the process. Thread, what is it? It is a smallest unit of execution inside a process. It is also called as lightweight process, has its own program. Each thread has its own program counter, register, and stack. Here it is a single thread process, it is a multi-thread process. Each thread has a own code, data, files, register, stack. So here also multi-thread also having the separate code, register, stack. And then which is and then coming to the difference between the process and thread. Process, which is nothing but it is a lightweight process. It is it is a lightweight process. Process is which is nothing but it is a very lightweight. And then the thread, which is it is heavy. Sorry, process is a heavy weight, and thread is a lightweight. Process is a heavy weight, and thread is a lightweight. And then separate memory is needed for process. Here thread there is a shared memory is used. Here more overhead, here less overhead. And in process slower creation is occur, and then thread faster creation is occurred. The advantages of thread. Thread is there are so many advantages in thread. Thread minimize contact switch time, efficient communication, faster contact switching, better, and then better CPU utilization, and also economical creations, and suitable for multiprocessor system. Disadvantages are it is a complex programming, synchronization problems occur, deadlock will occur, security risk, and difficult to debug. Types of threads are two types. One is user level thread, another one is kernel level thread. In user level thread, managed by user library, and operating system does not know about the this user level thread. There are so many advantages in that. It is fast creation, no kernel involvement, it is portable, it is managed by the user level library, not by the operating system. Advantages is it is a fast creation, no kernel involvement, it is very portable, easy to represent and manage. Disadvantages are there is a lack of coordination between thread and operating system. In kernel level thread, it is managed directly by the operating system. Operating system it is managed by the operating system. The advantages are it is true parallelism, better scheduling. If one thread block, others run. So the disadvantages are it is slower creation, more overhead. Advantages are better scheduling. If one thread blocks, others run. Difference between user level and kernel level. User level, which is nothing but here, it is faster, it is lower. The implementation by the thread library, only thread library knows. Here operating system support for a kernel level. Here UTL is generic and can run on the any operating system. Here Kernel level thread is specific to the operating system. Multi-thread cannot take advantages of multiprocessing. Kernel routine can be used in the multi-thread. And in multi-thread model, some operating system provide a combined user level thread and kernel level thread facility. There are three types of model. One is many to one model, one to one model, and many to many model. Here, one to one model, which is nothing but each user thread, each user thread is mapped to one kernel thread. Here, how it work means every thread is known to the operating system, so the true parallelism is possible here. The advantages are one thread block, others can run. It supports multi-core processor, better for performance for model systems. The disadvantages, it is very costly. Operating system limit number of threads, so there is a disadvantage in this type. So example is Windows Linux. And then many to one model, user level thread are mapped to one kernel level thread. Here how it is work means operating system sees only one thread. The thread manage is done by the user level thread library. Advantages, it is fast creation, easy to manage, no kernel environment for thread switching. Disadvantages, if one thread block, all thread block, so no parallelism execution here on multi-core CPUs. Example is old Unix system. And in many to many model, user thread are mapped to many kernel thread. How it works means it is a combination, combined benefits of both model, both user level and kernel level. So operating system can schedule kernel thread efficiently. So advantages are it is efficient to use, no blocking problems, support concurrently. So the disadvantage is commonly, it is less commonly used, complex to implement. Thank you.